A couple of years ago, the definition of generative AI fit inside a small, flat text box on your screen. These early systems relied on a unimodal architecture. Trained exclusively on text and code, their output was a continuous, one-dimensional string of characters. But human problems don't happen in a text document. Solving real-world tasks require sight to interpret images, sound to hear context, and spatial awareness to navigate physical environments. Because of that mismatch, text-only systems hit a functional ceiling. We reach the limit of what can be accomplished when a tool only knows how to read. By 2026, multimodal AI has become the default experience across enterprise platforms, moving beyond the novelty of isolated chat interfaces. This shift relies on shared embeddings. Instead of processing in separate silos, AI translates text, images, video, and audio into the same mathematical language. This lets models reason across diverse sources simultaneously, analyzing visual scenes and text queries in a single logical operation. This mathematical unification enables AI to interpret a photograph or a recording with the same logical depth previously reserved for written language, bridging the gap between abstract symbols and sensory data. With the first dimension left behind, AI stepped into the realm of sight and sound, shifting its role from merely analyzing media to synthesizing it. In audio, we see this through platforms like ElevenLabs, which can clone a human voice with striking emotional realism and perfect cadence, using only a few seconds of sample data. Musical generation followed immediately. Platforms like Suno now produce broadcast-quality songs instantly, assembling vocals, instrumentation, and mastering without any human recording. These systems are not retrieving pre-recorded clips.
They are constructing a completely original acoustic output based on a user-specific command. That same synthetic capability has made video generation the highest impact segment of the industry this year. Diffusion models powering Sora, Kling AI, and VO3 have learned the statistical relationships of motion, creating high-definition cinematic sequences from simple prompts. These models simulate complex physics, lighting, and camera movements in a matter of minutes. Yet no matter how photorealistic a video looks, it is still a two-dimensional projection restricted to a flat screen. To integrate with physical systems and professional design workflows, the intelligence needed to master a third coordinate, depth. That brings us to the most commercially significant category of 2026, the 3D generation frontier. Platforms like Meshi take a 2D photo and translate it into an export-ready 3D model. Other tools, like Spline AI, let developers build interactive 3D web environments using simple prompts, removing the need for specialized software expertise. This spatial capability provides the critical bridge between abstract digital intelligence and tangible physical application. This spatial capability immediately unlocks professional workflows in game development, complex architectural design, and e-commerce assets like virtual reality try-ons. Rendering these multi-dimensional environments is a physical process. It relies on specialized computational infrastructure operating in heavy-duty data centers. In 3 years, the technology has escalated from drafting flat messages to composing cinematic media, and now to constructing spatial assets. By integrating high-fidelity audio, video, and 3D spatial coordinates, these systems now operate as a comprehensive production layer, translating digital concepts into the structural assets we use to build the modern world.